Hi guys, this is Jake, and I'm here to talk to you today about ammonia and the Haber process. When growing crops on a scale needed to feed a population, it was found in the 19th century that other sources were required for nitrogen in the soil, so the crops would grow to the extent needed. It was quickly discovered that ammonia was the best way to artificially fertilise crops and was much better than traditional methods such as manure. However, the problem with the use of ammonia-based fertilisers is the difficulty in sourcing ammonia. This normally meant mining niter deposits. However, it was clear that these would not be able to sustain the amount of fertiliser needed. Synthetically producing ammonia at an industrial level was notoriously difficult, and most methods were high temperature with low yield and were very inefficient. Nitrogen is abundant in its natural form in the atmosphere, and however, N2 is highly stable and so is very difficult to use. However, in 1909, Fritz Haber managed to produce ammonia at a constant flow rate from atmospheric nitrogen, a rate of 125 millilitres per hour. This took immense pressure and temperatures in order to work, with a pressure of 2,200 psi to 3,600 psi, or 250 times normal atmospheric pressure, with a high temperature of 400 to 500 degrees Celsius. And a source of hydrogen gas was also required. This normally was from the steam reforming process, which required taking natural gas or methane and running it over a bed of nickel catalysts at a pressure of 360 to 510 psi and a temperature of 700 to 1100 degrees Celsius. To produce the necessary reaction from ammonia, however, a catalyst was still required. Haber found that an osmium catalyst was sufficient to provide enough of a base for nitrogen to separate from itself. While an inch passed through the reactor, the conversion rate is around 15%. By recycling the gases in the reactor, the overall conversion can be around 97%, making it much more efficient than previous systems. After the reaction was demonstrated, BASF, a German chemical company, bought the rights and commissioned Bosch to industrialize the procedure. Under Bosch, an iron catalyst was found by reducing high purity amounts of iron ore, magnetite or Fe3O4. This allowed a cheaper catalyst to be used, making the process industrial viable. Thank you very much for listening, guys. This has been Jake with Minecraft Chemistry.